All right, so we're going to look at this problem here and we're going to calculate a confidence interval. Now, confidence intervals look for the range of values that we can have. For this particular one, we're going to calculate two confidence intervals with a 90% confidence and a 95% confidence. And what we have is we have a random sample of 55 theaters with a mean price of $136. And a standard deviation of 15.5, and that's the population standard deviation. So I'm going to come over here and the things we need from this. So, whoops, where am I here? There we go. So our N was 55. Let me make sure I have that right. Yep, 55. Our sample mean was 136. And our population standard deviation was 55. Not 55, 1550. I knew there was double fives in there somewhere, but it's 1550. All right, flipping through screens here, 1550. And so a confidence interval consists of the values that restrain around the population's mean. And we can do this by subtracting an error from our sample mean and adding an error to our sample mean. And this gives us a range that our sample values might fall into with a given error. And so the confidence interval that we want first is 90%. And so if we look up on page 299 of our textbook what the Z critical value is for 90%, we're going to find that it's 1.645. So Z critical is equal to 1.645. So we're going to take Z critical times the standard deviation divided by the square root of n. Or in this case, it's 1.645 times 15.50 over the square root of 55. And for us, let me come here. So we have 1.645, 1.645, whoops, go back, 45, times 1550, $15.50, divided by the square root of 55. And so our error is 3.44. Well, 3.44. So we'll come back here and we'll say that E is approximately 3.44. So our confidence interval, our lower bound, is our x bar minus 3.44, which is 136 minus the, whoops, 0, minus the 3.44, or our lower bound is, I'm not going to flip over to the calculator for these. 136 minus 3.44 is 132.56, and the upper bound, I add them. So 136.00 plus 3.44, which is approximately 139.44. If I can write my fours properly here. And that's the 90% confidence. Okay. Well, for 95%, Z critical is 1.96. So I repeat this calculation with 1.96 times 15.50 over square root of 55. And I will show that calculation here. We'll come back. We'll go to calculator. I'll come up. I'll grab this so I don't have to type the same things in again. 1.96. Delete the extra digit. And I get 4.10. Right? We'll round this up to $4 and a dime. So 4.1. That should have been a plus. So x minus e. It's 136.00 minus 4.10. And so my lower bound at a 95% confidence is going to be 131.9, right? And my upper bound is going to be 136 point plus 4.10, which is 140.1. And so there we've created our confidence interval. Notice the greater confidence I have, the larger range of data I have to grab. To be confident, I need more things, one way or another. If I want to narrow my error, if I want to narrow this down, I need to get more samples. And so there's competing forces here. The more samples we take, the smaller the error width is. The more confidence we want to be, the larger the error width is, based off of the number of samples we have.